video cut out on me there, but I'm just picking up with example 4. I was about to find her monthly expenses, so just adding all of these up, plus 40, plus 65, getting 16, 15, $1,615. So I've got steps 1 and 2 done. Monthly pay is step 1. Monthly expenses is step 2. Step 3 is to find that difference. So 2669.33 minus 1615.00. Okay, so 2669.33 minus 1615 is 1054.33. So she's in a better place with her money than the person in the previous example. Okay. Now, we also know that, in addition, Gail receives $30 a week on average from a side consulting job. Okay, so that is something that we need to take into consideration before doing this, actually. So let's get rid of that, and let's make sure we read the whole problem before we find her total, her extra money per month. So her monthly pay is going to be an extra $120 per month because she makes $30 a week on average from a side consulting job. So taking that $30 a week, which they give us as an average, scaling it up by 4 to be monthly, I'm getting a new monthly pay, but also she gives $45 a month to charities. So we also need to expenses, we need to add $40 here. So we need to adjust her monthly pay and her monthly expenses. Her monthly pay becomes, 2,789.33, and her monthly expenses go up a little bit to 1,655. So the 120 came from multiplying 30 by 4 because that was a weekly average pay. $30 a week, that's weekly, so I scaled it up by 4 to become monthly. And the $45 a month, that's already, it's 45. Oh, dang it. Why did I write 40? 45. $1,660. There we go. The 45 is already a monthly expense, so no need to scale it up by 4 because it's already measured at monthly. Alright, now we can write down the difference of her monthly pay and her monthly expenses. And we're getting a new number, 1,120. Now, you may be thinking, oh, well, you could have just done that back here, probably, adding the 120 and then subtracting 45. Sure, but it's more appropriate to have all of your monthly pay and then all of your expenses, monthly expenses, and then to find the difference. It's just, that's how you would do it too in a spreadsheet if you asked a computer to do it. Like, we understand that it can be done on the back end from right here, but if you're going to ask a computer to do it, doing it this way, having everything lumped here, and then finding the difference, that's going to be the more efficient way. Now, of course, the rest of example 4, the solution, is all about putting it into a spreadsheet. You can read that if you'd like, but I'm not going to require you to do anything like that. But they do reach the same conclusion at the very end. We can now see that Gail has $1,129.33 to put towards expenses not in her budget each month. Alright, good. Alright, so the next few examples are going to have to do with prices and discounts of items, percentage discounts and such. So we should know the list price of an item is what it's listed as on the shelf. The price of an item as it is listed for public sale, as the book puts it. We should also know what a discount is. A discount typically is given as a percent, like 25% off or something like that. And it's something that you subtract from the list price. And a sale price, the way the book states it, is sometimes called the net price, is going to be the actual cost of the item after the discount is applied. So of course that's going to be, if you've got the price of an item on a shelf and you know its percentage discount, obviously the implied problem there is to figure out what is the new price of the item. That's going to be its sale price. Okay. Example 5 is finding the sale price. So Tennis Star Shoes is having a sale, alright? A pair of shoes has a list price, so this is what it's listed as, list price of $129.99. The store is offering a 25% discount off of this list price. So the discount is the percentage, 25%. Okay. Determine the sale price. Now the point is we can get this discount, which is measured as a percent of this, as a dollar number, right? Well, we can convert this to a decimal and then multiply it by this to get some chunk of this number, get it as a dollar amount. What I mean by that is we can take 0.25, which is the 25%, and multiply it by, because we want to know what is 25% of this number, the list price, and this is how we answer that. We're getting $32.50. That's the discount. So I could say the discount is 25% from that, or of that. In other words, if you wrote it as a dollar amount, if you're thinking of the discount as a dollar amount, there it is. That's critical to this problem. The sale price is going to be the $129.99 minus the discount, which is going to be $97.49 before taxes, they say. In the book, they emphasize that this is before taxes, and that's fine. Okay. We don't know the tax rate for this store, so we can't do anything more than this. This is the sale price, and that's all that was asked for. There's another way to do this problem, a little bit more efficient, and that is to say, if this is my discount and this is my list price, then my sale price is going to be list price minus discount, right? So another way to look at sale price is list price, $129.99, minus my discount. But what if this is my discount, right? $32.50. That's exactly what I did here. But what if I wrote it this way instead? Okay. So just taking this out of the equality before I actually multiplied. Oops, 129.99. Okay. And then what if I said, just, I'm not going to actually compute this because of course I would get the same answer, but I want to look at this and work with this a bit. And notice I can factor out that list price because it's listed here and here. I can pull it out using the distribution property in reverse, factoring out a number. This just turns into a 1, and then this second number turns into 0.25, so I'm pulling 129.99 off of both of these numbers, which of course just leaves a 1 in the place right here, in this position. Okay, and then I can say, well, 1 minus 0.25 is 0.75, and that's going to give me that 97.49 as well, of course, because these are all equivalent statements here. So what's going on here is I'm saying if the discount is 25%, then how much are you going to pay of the sale price? What is that number as a percentage? %75%, right? No, not sale price. You'll pay 75% of the list price. Sorry, you'll pay 75% of the list price. If the discount is 25%, then you will pay 75% of the list price. You see where that's coming from, right? 100%, which is the list price, is 100%, just the total, the actual number. Take away 25%, you're left with 75%. Okay, these are both legitimate ways of doing the problem. Whichever way makes more sense to you, you can do it that way. Okay, this time we are given the list price and the sale price and asked to find the discount as a percentage. So this is straight back to our percentage problems, looking at percent, amount, and base. Clearly we're looking for the percent here because they say what percentage is the discount. We just got to determine which number is the amount, which number is the base. Let me actually read the full problem here, though. Andrea bought a stereo on sale for $198.45. All right. $198.45. The list price of the stereo was $330.75. What percentage is the discount? So we're looking for the discount here. We're looking for the discount. Okay. Now, we need to make sure we know that we have to do some work with these numbers before we can get to a point of finding our base and amount. One of these numbers is our base, but the other one is not the amount that we're looking for. Okay, what we need to do first is discover what the discount is as a dollar amount. If you can get it as a dollar amount, you can get it as a percentage of the list price. So that's the first thing you need to do. And the most common mistake that I would guess that a student would make here is assuming that this number, 198.45, is the discount. But it's not. It's the sale price. How do you find the discount? You find that difference. You find the difference of these two. And just for fun, I'll do it by hand. Let's see, that would be 2, that would be, oh, okay, this stopped being fun. Okay, 2, 1, 3, 2, 12, 3, 1, okay. There's my discount as a dollar amount. What I need to know how much of a percentage of the list price gives me this discount. So I'm saying what percent of the list price, I'm going to write it in general here so you can apply this to other problems that also ask for a discount. What percent of list price is discount? Where this is my discount. So, in other words, I'm saying some percent times 330.75. Remember, of means multiply here. Is means equals. Dropping the dollar signs because I'm about to do math with these. So my percent is equal to, of course, how do I solve for the percent here? Well, it's attached by multiplication to this 330, so I'm going to divide that over to isolate my percent, and tack on the times 100% to get it as an actual percent instead of a decimal. So pop that into the calculator. Well, the book already did it for me. I'm getting 0.4 from this quotient here. Then times 100% gives me 40%. There's my discount. There's my discount. So when a problem is asking for discount, if you have sale price, list price, asking for discount, make sure you know this step 1. If I called it step 1 here, your step 1 should be to find the discount as a dollar amount. Sorry, obviously in the end we want the discount, but I meant as a dollar amount. Find your discount as a dollar amount by taking the difference of the sale price and the list price. Well, the sale price from the list price. That will give you your discount as a dollar amount. That's the number that gets plugged into this equation where you actually solve for the percent. Examples 7 and 8 deal with percentage increases and decreases. So just in case, well, and overall you can call that percentage change. So just in case you've forgotten, percentage change, I did not leave myself enough room here, is equal to it's a quotient. How did I write it in chapter 4? I could bust out my notes. Let's see. Okay, I pretty much wrote it all the same way. I just said difference over initial value. But the way they write it in the text on page 467 is new value minus reference value. I like to say new value minus original value. Because whenever, I still didn't leave myself room here. Okay, whenever you're measuring a percentage change, you're starting at some value and you're moving to a different value. So I like to call those two original value, like your starting point, and the new value. The book calls the original value a reference value. That's fine too, but I like to this is how I like to think of it. And in chapter 4, I wrote the top as I just wrote the word difference, which is that's what this is. A difference is a subtraction problem. And then of course we're going to tack on that 100% at the back, times 100% to get it as a percentage. Okay. By the way, here, this allows for negative values, possibly, if this original value is larger than the new value. And if you have a negative value, what does that mean for your percentage change? It was a decrease, right? If it's a positive value, it was an increase. All right. Example 7 says we're going to compute a percentage decrease. Freddie bought a tablet PC for $1,200. 1 year later, the same tablet PC cost $900. Determine the percentage decrease for the price of the tablet. Okay, so the original value, let me see, here we go. Original value, $1,200. New value, $900. Plug them in. Not much more to say there. Plug them in. 900 minus 1,200 divided by 1,200 times 100%. Of course, order of operations tells us to do this before the division because technically, I know division comes before subtraction, right? But technically, this is all grouped up here in the numerator. So we definitely do the subtraction first, which would be, so the reason I'm making a big deal out of that is if you plug this into your calculator, if you just kind of arbitrarily go, okay, 900 minus 1,200 divided by 1,200, you're going to get 899 because your calculator is going to think you want to do 900 minus and then 1200 over 1200. So the important thing to note here is that this is technically wrapped in parentheses here. So if you do want to use your calculator for this whole thing, make sure you're using the parentheses buttons. Wrap that numerator in parentheses. The way I was going to do it though is just go ahead and find that difference and just put that, bring that down. Negative 300, just doing that separately, and then dividing this would be, that's 1/4, right? 3 out of 12, canceling the extra zeros. That's a quarter, 0.25, it's negative. Times 100% is going to give me negative 25%. And like I said, if it's negative, it was a decrease. I mean, they already told us it was a decrease anyways. But in case it wasn't clear enough, there's a negative percentage. Now, also recall that if you've got multiple new values going on, so this is from one year to the next. What if they told us the next year the value was $800? Then there's potential for 3 different types of percentage decreases. So let me say. So what if next year the tablet costs $800? Well, then we know from year 1 to year 2, so from 1200 to 900 yields a negative 25%, right, or a 25% decrease. What about from 900 to 800? 900 to 800, what is that as a percentage? So I could find the difference, 900 to 800, so I would do 800 new value minus 900 equals negative 100. So I'm just plugging in, I'm using 800 and 900 as my new and original values. So from here, from 900 to 800 would be a smaller decrease, like 11.11%. I could have just rounded to 11%. And then also, we can look at all the way from year 1 to year 3, 1200 to 800. How would you do that? You would take the difference, 800 minus 1200, divided by that original value, which is now 1200, times 100 to get it as a percent. That gives me negative 33%, 0.3 repeating. 3 different types of percentage decreases going on here if a question like this is asked, right? So be wary of that. Be wary of that. When you've got multiple years going on and you're asking for a percentage decrease or increase, be absolutely sure of which year to which year, or whatever the context is, usually year to year, what they're asking for. Are they asking from 1 to 2? Because that's one answer. Are they asking from 2 to 3? That's a different answer. Or are they asking from 1 to 3? Different answer. And what if they're asking from 3 to 1? What if they're asking from 3 to 1? Different answer again. What would that be? What would that be? Well, it would be the same as this, except not negative, right? Okay. All right. Let's look at example 8. Okay, so now we're going to be computing a list price from a given wholesale price and a desired profit margin. So they call this example 8 at the top, they call it computing percentage increase. That is a bad name, because that implies that we would be using that formula that we just used for computing the percentage decrease in example 7. It's not what's going on here. Instead, this is going from a wholesale price and a profit margin to a list price. In other words, we're not the consumers at this point. We are the salespeople. We are buying a bike at a wholesale price of $450. We want a profit margin. Profit margin means how much of this is going to be our profit. And it's given as a percentage. No, I said that bad. Let me say that a bit clearer. First of all, it is given as a percentage. Your profit margin is going to be how much money you want to make based off of selling this item. But they didn't give it to us as a dollar amount. We can get it as a dollar amount, and we will. They gave it to us as a percentage, meaning that this company wants to buy bikes and then sell them with a 40% increase in sales. That's why they call it a percentage increase. So they should be making a profit margin of 40%, meaning this much more money back from selling the bike. And what do we want? We want that list price. The list price is going to be equal to, of course, wholesale price has got to be in there, plus profit margin times wholesale price. Your list price is going to be that original wholesale price plus profit margin times wholesale price. It's kind of the opposite of a discount, right? Because we're not playing the role of the consumer. Again, we're playing the role of the person selling the item. They want to make a profit. Okay, so here what we're going to have is our wholesale price at, so let me come over a bit, list price. Get all this in one line here. Okay, $450 wholesale price, plus 40% is my profit margin, okay, as a decimal, 0.4, times, so this is going to be the 40% of the 450. This is going to be what my profit margin is as a dollar amount. This right here will give me my profit margin as a dollar amount. You may choose to do that separately and then add it on. I'm just kind of doing it all at once here. By the way, I could do the same thing I did. Well, you know what? No, I'll do that later. All right, I'll do it in green later. So 0.4 times 450 is 180. There's my profit margin as a dollar amount. And then finally, taking the sum of these to get the actual list price, getting $630. So let me say it one more time. This is that is the profit margin as a dollar amount based off of the wholesale price. Okay, I said there's another way to do this problem. There is, kind of points out another way of looking at it. I've got the 450 plus 0.4 times 450, but of course, just like that other problem, well, I don't even remember what example it was, but we can factor out a 450, leaving us with 1 plus 0.4. That's going to be 450 times 1.4, which of course, like, mathematically leads to the same conclusion, so what's the big deal? Well, the point is that this as a percentage is 140%. So the point is, if you want a profit margin of 40%, then multiply your wholesale price by what? By 140% to get the list price. It's the same thing, right? It's saying the same thing, just looking at it from two different points of view. The first way I did it, I had the wholesale price, and then I found the percentage of the wholesale price that's going to be my profit margin, and then I added them together. Here I'm saying, well, if I have my wholesale price, that's 100% of that item, and then my profit margin at 40%, add those percentages together, gives me 140%. And then I'll just take my wholesale price and multiply by that new percentage. Which, of course, that's what 1.4 is, the 140%, right? That's the point right there. So, that's all the examples, but I want to look at this skill check problem. It's called skill check number 4. In the text, it says use the list price of $630 for the bike in example 8 to find the sale price if the bike was reduced by 40%. So we have our list price that we found. We have a discount of 40%. And we want to know the sale price. The sale price. But remember, sale price is just going to be equal to list price minus discount as a dollar amount, though. Remember that. Remember, discount as a dollar amount. Not just minus 40, right, or 0.4. It's discount as a dollar amount. So let me go ahead and find what that discount is as a dollar amount. If I know it's 40% of 630, okay, so my discount as a dollar amount is going to be 630 times 40%, or 0.4. 0.4, that's going to give me, what? 630 times 0.4, there we go. $252. So my sale price then is going to be my list price minus the discount as a dollar amount. What is that? 378. Okay. So this is pretty similar to a previous example we did talking about discounts, except this time we didn't have the sale price. The first example we did with the discount, we were actually looking for the discount as a percentage, and we were given list and sale price. So this is like a different iteration of a similar problem. But again, emphasizing that when you take your discount away, you're getting that discount as a dollar amount here. But another thing to point out is that this is not the same. You notice the percentages are the same, the profit margin and the discount. So why didn't these answers work out to be the same here? Why didn't we get 450? Because essentially what I'm doing in example 8 is I'm adding 40% on, in a way, right? I'm adding 40% of this onto it to get 630. And then here, I'm taking 40% away from 630. So why didn't it work out to be the same? Well, because this 40% is based off of 450. which is a smaller number. So this 40% gave me this 180, whereas this 40% is based off of 630, a larger number, gave me 252. Oh, there it is, 252. So percentages are relative, right? They're relative to whatever number you're taking them from. If you're taking 40% of 450, you should expect a number that would be smaller than 40% of 630. Okay, good. Let me find some example or exercise problems for you to look at. Okay, try these 4 problems as a part of a review for when you're reviewing for the exam that covers this section. 1, 7, 8, 13.